So you want to learn Postgres, huh? Well, I know a thing or two about Postgres. In fact, I would say that learning Postgres and SQL has been one of the most beneficial skills I've learned throughout my entire career. Not only has it been helpful on the job, it's also been a really impressive skill to be able to flex in interviews with potential employers, and I've landed multiple contract jobs just because I know Postgres well enough to be able to do things that other developers simply can't. Today, in this video, I'm going to give you some initial skills to help you on your journey to Postgres mastery. We're just going to be talking about a lot of the basics. Perhaps in future videos, we'll dive a little bit deeper and talk about some more advanced concepts, but this should lay the foundation for your journey to Postgres mastery. So without further ado, let's dive right in. So the first question is, what is Postgres? What is SQL, really? Well, Postgres is a relational database. You're going to hear a lot about relational and non-relational databases out there. And an initial assumption a lot of developers might have, and in fact, when I used to teach, I would ask students a lot, what's your assumption? What do you think relational means versus non-relational? And oftentimes, they would say, well, I would just assume that a relational database allows you to relate data together. And while that's true, you can do that in a relational database. What's also true is that you can do that in a non-relational database. What it actually is talking about is the math under the hood, what makes the database tick. In relational databases, it's leveraging relational algebra. And that's the reason for the name. So that's just a common misconception that I wanted to clear up before we dove right into Postgres. So SQL stands for Structured Query Language. It's a language that allows us to communicate with our database and make changes by using a series of keywords. We're going to dive into it a little bit more, but just setting the stage for the rest of our talk today. So let's go ahead and talk about the core building block for essentially all SQL databases, which is tables. And tables they're essentially containers for data. They're made up of columns and rows. You can think much like an Excel spreadsheet or a Google Sheets spreadsheet. You're going to have a series of columns, and then you're going to have multiple rows. Oftentimes, we'll talk about entries into a table as entities. So if you ever hear me talk about an entity, I'm just talking about one object in the database. So for example, here, what I would say is maybe this first user here, he's an entity in the database. And what we can see is this is actually a screenshot from the editor that we'll be in soon, is we have a series of these columns here. So we've got an ID column, email column, name column, age column, and password column. And what you'll also see is that we have these rows. We have these entries into that table, and those rows have specific entries for each column. So for example, for the email column, we're going to see troy@fakeemail.com is this user's email address. And then, same for name, same for age, and password here. These are actually hashed. You're never really going to store raw text passwords in a database. It's a huge security concern. We're not going to talk about that much in this video. Maybe that's a great topic for future ones, but I just wanted to explain why you're seeing that nonsense in the password column. Okay, so let's jump over to an editor now, and let's create our first table together. All right, so welcome to Postico. Postico is just an interface for interacting with Postgres. I'll have some links for setting up Postgres on your local machine as well as Postico down below in the description. But all you need to know for now is it's an editor that allows us to write SQL and interact with our database. It also gives us a nice UI so that we can see things. It's fantastic for beginners. So let's jump right in. So here, this is where we're going to write our SQL. So, we can type away as normal, but SQL, like I said, is made up of a series of keywords. So what do I say when I mean keyword? Well, a keyword is just a word that tells SQL to do a very specific operation. And in this example, what we want to do is tell SQL, or tell Postgres, I should say, to create a table. Okay? So what table are we creating today? Well, I think it's best to go through anything new that we're learning with a actual realistic example. So we're going to build a little bit of a schema here that would represent an application that allows us to have users and posts eventually. And when I say schema, all a schema is it's just the database itself. The way that data is laid out is the schema. Okay, fantastic. So let's jump into it. First, we're going to create a table. I'm going to call the table profile for now. I'm going to revisit that, but we'll come back to it. And then the syntax for this is after we say create table profile, we open up these parentheses here, and then inside of here, each line, we're going to define a new column for that table. Troy from the future here. I'm sorry for the interruption. I just want to note that SQL statements need to end in a semicolon. I didn't specifically say that, which is my bad, but you'll notice that every statement that I write throughout this entire video ends in a semicolon. It's how we tell SQL that the statement is done. So we always, whenever you're working with the database, you need to make sure that you have an ID column. That column is going to be what we call a serial column. And we're going to go ahead and also tell it that this is the primary key. The user might also have a name. The name we're going to say is varchar 255. And don't worry, I'm going to come back and talk through all of this. What does this stuff mean? You might not know, but I think it's helpful to write it all out first so that you can see it together. We're going to have an email. That's also going to be varchar 255. We're going to have a password. I'm going to make the password text. And then finally, we're going to have an age, which is an integer. Okay, great. So what does all of this mean? And why are there these different capitalizations for certain words and then some not? Okay, so first things first, let's address capitalization. In programming languages, you're going to have a series of conventions oftentimes. In languages like JavaScript, you're going to see a lot of camel cases. In Python, you're going to see a lot of snake casing. In SQL, the convention is that you uppercase all keywords, and anything that relates to your table itself should be lowercase snake case. So all lowercase characters snake case. The reason that is SQL does not care about casing. So this is the same thing. It's going to do the same operation. Me lowercasing create had no effect on it. But you write code for other people, and it's important to structure things in a way that makes it easy to read. So here, by uppercasing everything that's a keyword, it becomes very, very clear what is baked into Postgres itself and what is something that I'm naming, what is something that I have control over. So here, this profile name, this is a name I'm giving. It could be anything I want virtually. I could call this person. I could call this user. But for now, we may call it profile. I want to come back to that user point, but that's the idea, is that you're uppercasing all of the keywords, and anything that is lowercase is something you're naming yourself. So let's follow that to the next line. In fact, I'm going to skip over ID for a second because it's the most complex column we have. We're going to talk about name next. So name here, that's, well, the name of the column. I'm creating a column and I'm calling it name. And this is something to look out for the entirety of this video. Is anytime you see something that's lowercase, you should assume that it's something that I'm naming. It's not something that's built into Postgres itself. Next, we have this, which is a data type. The data type is what constraints we're placing on this column itself. And for me, this is what makes using relational databases so powerful. You can add constraints to your columns. Data does not just exist in containers that have rules that are made up. They are enforced by the database itself. I could not insert just a raw number into the name column if I wanted to. And the reason is I'm telling Postgres here that this column is varchar 255. What is varchar? That's a great question, you might ask. This is the syntax for a comment. So I'm just, I can write anything in here. It doesn't matter. The editor ignores it. I'm just commenting on the column, and it's good for taking notes. So what I'm going to say here is varchar, and I'll uppercase it, is a text column that has a constraint on size. Okay. And I know it's overflowing a little bit to the next line, but this is the same line. So the idea here is that varchar is a text-based column, but critically, it has a constraint on how long that text can be. And the upper bounds for that is 255 characters, right? So The max we can do is varchar 255, but varchar 50 is valid as well, and I think it's probably fine for name, right? It's pretty rare to have a name that's greater than 50 characters. Maybe for covering all of our bases, we'll do a 100 character name column. So what this means is that this column is only going to take up enough space to show 100 characters, and it's a great way to optimize your database so that you're not consuming more data than you need. So here, again, we're saying that this name column is a text column, and it can only max out at 100 characters. For email, it's the same thing. I'll leave 255. You can have some long emails. We'll leave 255. And then password is just plain text. And the reason you would do that is that at least for applications I've worked on, and pretty much any app that you're ever going to touch, actually, you're going to be hashing passwords in the database. And password hashes can get pretty long depending on what hashing library you're using and what hashing algorithm you're using, whether you're using SHA or MD5. Anyways, that's not important for this talk. The point is I'm making password text because placing constraints on something that's going to be hashed, it's kind of silly. Next up, we have age, which is an integer. An integer is, it's straightforward. It's a number itself. So you're going to see, numbers in here like 20, etc. I want to note that there's a lot of different types for your columns, and if you want an exhaustive list of them, you can Google Postgres column types, and you'll get an extremely large list of all the different types. One of those such types is serial. Okay, serial is a special type because it sets up some additional stuff for us, some additional stuff that I'll dive into more in a future advanced Postgres tutorial. But for now, the way I want you to think of this column is an integer that automatically adds 1 for us. Every new entity. So every single time we insert into this table, it will automatically add 1 to the ID column. And what I mean by that is our first profile that we insert, the ID will be 1. It starts at 1 with a serial column. Then the next one, we don't have to do anything. It'll just automatically get the ID of 2. The ID column is something you never want to edit yourself. You want to let the database handle this. When you're inserting profiles later, and we'll talk about this a bit more when we're actually inserting data momentarily, but we want to avoid touching this column. This column is something we want the database to control. The next part is the primary key. So primary key is just telling the database that this is the key that we're using to represent each row in the table. And critically, that also means that it's going to be unique, right? We shouldn't have multiple profiles that have the same ID. It's a unique identifier that we can then use later on to reference for specific rows. It's incredibly useful, and we'll show that more as we get later into the crash course. So again, serial is a data type. It's an integer that automatically does +1 every time. So without further ado, let's go ahead and execute this statement. So it worked. That's what this create table is. And I can show you it worked because PostgreSQL is awesome. And if we come back here to the lecture DB and we hit this refresh icon at the top, you'll notice that there's this profile table here. And if we click into it, we're seeing ID, name, email, password, and age. I'm sorry if that's a bit small. I tried to increase the font up there, but I couldn't. But that's our table. It's there. It does exist. But you might be saying, Troy, it seems kind of weird to call it a profile. This seems like this table should probably be called user. Well, if we run this, it's gonna fail, and we're getting syntax error at or near user. That's a bit strange. Think for a minute why that might happen, and you might get a bit of a hint by the coloring here. So pause the video if you want a second to just think about why that could happen. All right, here's why. This is a keyword. So creating a table that's called table wouldn't work because, like I said at the start, SQL doesn't care about casing. So when it sees this lowercase table, it's treating it the same as the uppercase one, and it thinks that it's a keyword, right? So it's seeing some syntax error. It's like, hey, you're using a keyword here. We're expecting a name. There's an easy way to omit this. Whenever you're trying to name something in SQL or reference something that is not a keyword but happens to share the same name as one, you can wrap it in very specifically double quotes. So we can say user. Now this works and we get a user table. So if we refresh, we'll see the user table. One last note on tables before we move on. You'll notice I'm calling it the user table, not users. The reason for this is that the convention that you'll often see in Postgres is that you name tables as singular items. And the thought behind that is that you think about tables as this bag that you put things in. And because of that, when you're talking about it, it's really useful to think of it as a user table, right? It's a bag to contain things. So you wouldn't say you would say you have a bag of candy, not you have bags of candy, right? Unless you have multiple. So that's the thought process. And I've seen it broken. I've worked at companies before that pluralize tables. It doesn't really matter, right? It's not going to make a big difference on your software itself, but there are times when you'll have tools that automatically generate things for you based off of your table names. Rails and Ruby are a great example of that. Rails will automatically generate a lot of code for you as long as you follow good conventions. And the other thing is, it's a convention. It's what other developers will be expecting from your work. So I think it's important to keep them singular whenever possible. And if you ever work with or for me, and I see a pluralized table in your code, I'm going to come at you a little bit. You're going to have to be prepared for me to shoot down your code review and tell you need to go change that. Okay, great. So we've got our user and profile in place. We're going to go ahead and drop the profile table. This is really, really easy. In PostgreSQL, you can just right click and delete, and it's gone. In order to do that in SQL, you can just say drop table and then the table name. But we have an editor. I would recommend using an editor, especially as you're getting started with SQL. And I think PostgreSQL is a great option. Okay, we've got our table in place. We're very excited about that. Now we just need to get data inside. We're going to learn some new ones here. We're going to say insert into our table name, which is user. And remember, user here happens to also be a keyword, so we're going to wrap it in double quotes. Then in parentheses, we specify what columns we want to insert. Well, those columns are email, name, age, and password. You might be asking yourself or thinking, why isn't ID here? We surely want an ID for each user. Well, if you remember back to when we were talking about creating a table, the ID is of data type serial. What that means is it's going to automatically generate an integer ID for us every new row. So we don't have to insert it ourselves. In fact, it would be a mistake to. This user that we insert will automatically have the ID of 1 for us because of Postgres' serial data type. Let's go ahead and move on with the query. So we've got insert into user. The columns we're inserting, email, name, age, and password. And then we say the values, which is a keyword. And now we can start to enter those values. And how this works is within these parentheses, we go in the same order that the columns are listed in these. So the order here doesn't matter. We can order this however we want. We just need to make sure we follow the order after the values keyword. So within here. So what that means is email needs to come first here when we're entering the value, name second, age third, and password fourth. So for email, I'm going to go ahead and enter Troy@fake.email. For name, I'm going to enter Troy. For age, I'll enter 26. And for password, I'll enter some nonsense. Okay, this is great. We've got our values in place, and if we run this, it should work. But you might have a question. What are these single quotes doing here? Well, single quotes are how we tell SQL that we're entering some text. So this is just looked at by SQL as text. It's not read as if it was part of the code itself. So if we put some SQL in here, this would get inserted as the actual email. Or sorry, let me use something you're familiar with. We haven't gotten to create statement or to select statements yet. I'm getting ahead of myself. If we put like create table in here, this will get inserted as the email, right? It's not gonna look at this as code. It looks at it as text. And in fact, without it, it will look at it as code. So if I omit those single quotes, it will read this and we'll get a syntax error because it doesn't know what troy@fake.email is. We need the single quotes to tell it that this is a string value. It's also important to call out if you've done other programming languages before, which if you're looking at this course, you probably have. Single quotes and double quotes are not the same here, which they are in a lot of programming languages like JavaScript, for example. And double quotes here are specifically for referencing columns and tables, and whenever you use them, SQL will expect you to be referencing one as such. And the same with single quotes. If we swap these two and it's double quotes here and single quotes here, we're going to get a syntax error. It's important to recognize the difference between those two. Age is an integer. Integers are not text-based data. They're not a string. So we can just put it, in line here. We don't need to wrap it in anything. Okay, fantastic. Let's execute that statement. We say we've inserted. And if we come back and look at our table here and refresh, you will notice, and I know it's a bit hard to see, I'm sorry about that, but the table's there and all of our information is in there correctly. This is great. I'm really, really happy that worked. And in fact, let's go ahead and insert another user just for practice sake. Okay, I'm going to insert another user. We're going to make it Chris at another.example. The person's name is going to be, you're never going to believe it, it's Chris. He's a notorious 98-year-old man who's using our application. And his password is wow, I love SQL 28. And we'll go ahead and insert Chris. It does work, and we can come back and look at our user table. And sure enough, he's along with Troy now. All right, that's great news. We've got 2 rows in there. Now, you might be thinking about something, and I hope you are. What do you do if you don't have a nice editor like this? How do you get information out? And in fact, what is this editor maybe doing under the hood to show us this data? Well, friends, that's what we're going to talk about next, and it leads us to some more keywords. The next keyword that we unlock in our journey to SQL mastery is going to be select. Select is a keyword that allows us to fetch information from existing tables. It's what Postgres is using under the hood to show us our entries when we go and we click on the user table here. This is how it's grabbing information. And remember, you're not always going to have access to a nice editor like this. And also, select gives us additional tools that make it even better sometimes than just viewing the data in an editor. And we'll show you that more later on in the video. But let's cover the basics for now, which of course starts with the select keyword. So I'm going to go ahead and write out a basic select statement, and then we'll break it down. All right, fantastic. Select star from user, and let's run it. And we can see here in the bottom, this is our SQL output, that those rows show up in the user table. The user table is there. Now I want you to think for a moment. What does this star probably mean? You can probably easily infer what from means. Select is clearly a keyword that's initiating this statement. What do you think this star means? Pause the video here and contemplate with yourself. So when I taught, most students would assume that it meant all rows. It doesn't. It means all columns. So this star is referring to what columns you want from user, and star means all. I can say, I just want the name. And when we run this, we're only going to see Troy and Chris here. It's only giving me the name back. I can say I just want the email, and it's only going to give me the email. Or I can do some combination. Give me the ID, the email, and the name. And there you go. Fantastic. Well, that brings up a question. We'll go back to select star so we can see everything. How do we say that we only want specific entries? And it's a good question. The way we do this is with the where keyword. we can select all columns from the user table, where, and then some condition. So my condition might be where the name is Troy. And if we run this, we're only going to see that single Troy row. We can do this with any combination of different conditions. So I could also say, maybe get me all the users where the age is greater than 20. We'll see both of our users in that case. But if we change this to 27, we're only going to see Chris. There's a lot of different conditions that you can use with a where statement. I would encourage you to look up a more exhaustive list than I'm able to go through here. But it's extremely powerful, and it's our way where we can specify specifically what rows we want to see. And then later on, when we're talking about update and delete statements, where statements become critical because it allows us to specify what rows we want to specifically affect from our queries. All right, so we've got data in. We're able to select it. We're able to say, give me the user with the ID of 1. Give me the user with the ID of 2. We have that power now. The next thing we need to learn is how do we change data? We've got these users in place. What happens when we made a mistake? Troy is not 26, he's 30, and we need to update that user. How do we do that? All right, so we've just unlocked our ability to select information. Now we need to be able to change it. So like I mentioned, we want to be able to change this row from age 26 to age 30. How do we do that? Well, in order to do it, we're yet again going to need some new keywords. Those keywords are update and set. So the way we construct an update statement is we initiate it off with the update keyword, and then we tell it what table we're going to be updating. In our case, that's the user table. Then we say what we would like to change. I'm going to say set the age equal to 30. Okay, so we're saying update user, set age equal to 30. Where, and then we use that where statement again. Remember it from select. This is how we drill down into it. Without this, if I was to just say set age to 30, it would update every user. Anytime you're writing an update statement, and then later on I'll reiterate for deletes, we need to make sure that we're specifying a condition, or we're going to make that update to everything. It's a really, really good way to have some embarrassing conversations in your first engineering job. So let's make sure we're using our where condition. We'll say where the ID is 1. Okay, so this is our condition. We're saying update the user table, set the age to be 30, where the ID is currently 1. And then the update went through. Let's use our new skill, and let's select star from user where ID is 1. Okay, and again, we have to wrap this in double quotes. Okay, and then we'll go ahead and we'll remove this statement for now. We'll come back and revisit it, but let's just see if we've got the update going through, and we did. His age is now 30. That's awesome. It worked. All right, great. So that's the basics for update statements. I want to make one additional note, and it's about this equal operator. The equal operator, as well as a lot of operators in SQL, they change based off of the context in which you use them. This one here is being used to construct a condition because it's prefaced by a where statement. This one here is being used to assign a value, and that's because it's prefaced by a set. It's important to separate those two in your mind, and remember that the equal sign operator changes based off of the context in which it's being used. Okay, great. That's the basics of update statements. We could use this to update any of the columns, really. But again, we want to avoid updating the ID. But maybe, just for the sake of another example, maybe we go ahead and we update the email of that same user to be troy@test.fake. And these are obviously fake emails, but we go ahead and update that, and then, select. Maybe I just want to see the email from user where ID is 1. And there you go. The email has been updated. That's fantastic. So we've learned how to do almost all of the basic operations. There's just one more left, and that's removing information. What happens when we have a user that we want to delete, right? This is an applications database. We might want to remove users, allow them to delete their account entirely. How would we do that in SQL? Well, the way we do that is with delete statements. And they start with a new keyword. We say delete, then we say what table it's from. We'll specify user. And then another call out here. Don't run this query. The whole table is gone if we run this query. We need a where condition, just like we needed with the update query. We're going to delete from user where the ID equals 2. Maybe our 98-year-old friend Chris is done using the application. We got to get rid of him. So we'll go ahead and delete him. Again, don't run just delete from user in isolation. Make sure you're specifying the condition so it knows what to delete. So we've gone ahead and deleted that user. And if we go and we select all from user, so we'll get all the users, we're going to see, sure enough, there's only one user left, and that's Troy. All right. That's the basic operations. With that, you can do full CRUD, create, read, update, delete operations on any table of your choosing. That's the basics, the building blocks of SQL. But now we need to talk about something just a shred more advanced, and that's that data does not live alone. Data is related to one another, right? You don't just have users in your application. And for our application, we're going to also have posts. Let's talk about how to relate information together in SQL. I brought you back to everyone's favorite realm. It's the PowerPoint realm, and we're going to talk about table relationships. So tables can have relationships with other tables. And I'm not talking about the bachelor type. I'm talking about data relating to another piece of data. So information in our applications does not live alone. Things have relationships with one another. If you think about the site you're on right now, YouTube, each of these videos have comments. How does that relationship work? How do we relate those things together? Well, the way we relate those together is through foreign keys. And those foreign keys allow us to reference specific entities in another table from a table. So I'll show you exactly what I mean with one of these examples here. Let's go ahead and look at our user post example. That one is actually a bit covered up by me. Okay, let's look at the avatar example here. So the user table here, and this is just real quick, I want to touch on what this is. This is what we would call an entity relationship diagram. So it's showcasing from a high level how our tables are laid out and related. So here we have that user table that we made, but you'll notice we've added something new. It's the avatar ID. That avatar ID is referencing a row, an entity in the avatar table. It's a new table. And then the avatar itself has a user ID that's referencing back to this user's ID. So it's related in that manner. Basically, what that means is that each new user might have an avatar ID. So say we have that user 1, it's Troy. We all know and love him. He's got the avatar ID 3. What that tells SQL is that if you go over to that avatar table and you look for the avatar where the ID is equal to 3, you will find Troy's avatar. That kind of relationship where a user has one avatar and each avatar belongs to one user, that's called a one-to-one relationship. There's 3 different relationship types when we're using relational databases. There's a one-to-one, like this user and avatar relationship, where one user has one avatar and one avatar belongs to one user. Then there's one-to-many, and this is the most common type, and it's the example we'll be using in our code. One-to-many is when one entity has multiple of another entity. A great example is users and posts. Another good example is the YouTube video we have and comments. A YouTube video has multiple comments. So you might imagine that in YouTube's internal system, they have a video table, and then that video table exists with no foreign key, and then there's this other separate comments table that has video IDs on each one. We'll break those down more in further slides. Let's jump in and talk about each one of the 3 relationship types in depth. The final one's many to many. We'll get there. I know it's on the bullet point. I don't want to make anyone nervous. I just don't have a photo for it. let's talk about one-to-one. One-to-one is the easiest type of relationship to wrap your head around. A user here has an avatar ID. An avatar has a user ID. So each row in the user table will have an ID referencing a very specific entity in the avatar table. We talked about this on the last slide, but let's reiterate again. Say you have Troy. He's got the ID of 1. We all know and love him. We made him ourselves. He's now got an avatar ID. That avatar ID references the row in the avatar table in which you will find Troy's avatar. So if Troy has the avatar ID 3, we would go to the avatar table and look for, maybe you write a select statement, select for the avatar where the avatar ID is 3, and then you'll see Troy's avatar is sitting there. And just the same in reverse. That's the critical part here, is that the avatar also has the user ID, right? That user ID is referencing back to Troy. That's what makes it a one-to-one. I want to note that although this example is one of the easiest to go through, one-to-one relationships are an easy thing to wrap your head around, they're actually the least useful, and it's something you won't see a ton. Oftentimes, they're used to just avoid column bloat, which is when a table gets out of hand because over time you're continuously adding more and more things to an application. So oftentimes you'll see it to just avoid bloating the size of your tables by spreading out information across multiple. The next type of relationship is a one-to-many. One-to-many relationships are the most common one you're going to see. And in fact, the next relationship we look at, which is a many-to-many, is just actually 2 one-to-manys. But we're getting ahead of ourselves. Let's talk about one-to-many. So one-to-many is when one entity has many of another entities, or they can potentially have many of another entities. And let's talk about that example a bit more in the context of YouTube in this video. This video has multiple comments, right? But it doesn't need to have multiple comments. In fact, when you're watching this right now, it might not have any comments. And if that's the case, you could be the first one, please. But anyways, the point is the entity, which is the video in YouTube's case, has the potential to have multiple comments, even if it doesn't yet. And the way that we set that up is through a one-to-many relationship. Let's jump back to thinking about our specific example, which is a user and a post. A user has multiple posts. And the way we set that up is we keep our user table as is. You'll notice it's the same. It's unchanged. But now we've created this post table. And the post table has the user ID. In a one-to-many relationship, it's up to the many to say who owns it, right? Each entity of that post will tell us who owns that user. And the reason is we can't put a post ID on a user because that would mean that each user can only have one post, which isn't the case. The user cannot reference posts. The post needs to reference the user. When we dive into actually making this post table, I'll reiterate that and elaborate just a hair more to make sure you wrap your head around it. But in relationships, the many references the one, not the other way around. And again, the reason is that would constrain the user to only being able to have one thing, right? Because if you think about it, each of these posts has a user ID. That user ID can only exist once per post. So the post belongs to the user. If we invert that and the user has a post ID, that would mean the user could only have one post, just like they can only have one name. But they don't. They don't have a post ID here. And that omitting of that column allows the user to have multiple posts through this post table. Let's talk about the final relationship, which is a many-to-many. This one is a bit more complex, and in complicated schemas, you'll see it a lot. But don't freak out. Don't freak out that we have 3 tables now. All we want to focus on here is that if you look at these tables in isolation, they're actually just 2 one-to-manys, which you're comfortable with. So all a many-to-many is it relates 2 separate tables to each other through one center table. And we typically call that table a join table. So we've got a one-to-many over here and another one-to-many over here. Those are related together through a join table. The best example I could think of for this was a school setup. So you have in a school students or users that are taking classes from instructors. An instructor has multiple students, and a student will have multiple instructors. So how do we relate that stuff together? Well, we relate them together through the class, right? So we have a user. A user has a class here. This class, as such, has the user ID. Remember, the user has nothing about the class because it owns the class. The class is the one who references the owner. Now, that instructor is also teaching a class. So as such, they have their instructor ID on the class. And you'll notice that these are two separate one-to-many relationships, but through them, we have the ability for a user to have multiple classes, and then each of those classes could have different instructors. And because of that, you could say that a user has many instructors through this class table, and that's true in inverse as well. Okay, we're back in PostgreSQL world, and we're ready to create our post table. So let's go ahead and start with create table. You guys know this now. We're going to create the post table. Think about why I don't have to wrap this in quotes. Remember back to past in the lecture? Why don't I have to wrap that in quotes? Make sure you know. Make sure you know why. I'm going to create the table post. It's going to need, just like every table, an ID, which is a serial primary key. And then we're going to give it a name for the post itself. Maybe this is a varchar at 255. You're maxing out at 255 characters for the name. Then content, which we can go ahead and make text. And finally, that foreign key. What relates the post to the user is a user ID. Each post will have the ID associated with the user that made said post. And we'll go ahead and just make it an integer. Next, what we need to do is we need to tell Postgres that this user ID is not just a normal integer, it's a special integer. It's a foreign key. And the way we do that is by creating a constraint. We can come and say constraint. I can type, I can text. Constraint, and then we give the constraint a name. I'll call it fk user, which is just a convention. It means foreign key for the user. Then we can say it's a foreign key. Then we tell it what column the foreign key belongs to, which is in our case is the user ID. Next, we tell it what that column is referencing. Well, it references the user ID column. And now this here is referencing the table. So we'll say user and ID. So again, at the end of our create table, we're creating a constraint. The constraint is that we have a foreign key. The foreign key here is what column we're talking about, the user ID. And then we tell it what that foreign key is for. It's referencing the user table ID column. So we're saying this user ID column in the post table is referencing the ID column in the user table. We'll go ahead and execute that statement, and our table is made. If we go ahead and refresh PostgreSQL here, we'll see now that that post table is there. And if we look, it has this nice structure tab for us. Just for us to confirm that it worked, we'll see user ID, and I know it might be a bit small, but here where it has a constraint where it's referencing, it's got this arrow to user.id. It's a foreign key. We've got it separate, or we've got it set up properly. Okay, we made our table with the foreign key. Let's go ahead and insert into this table. So we could just write an insert, but remember we have a constraint. Each post needs to belong to a user. So let's just quickly review what users we have in our table. And excuse me, I have to wrap that in double quotes. And there we go. We have just the one, and they've got the ID of 1. So let's remember that we're inserting for ID 1. So we'll go ahead and construct our post insert now. We'll do insert into post. And again, we don't have to wrap this in double quotes. You guys know that. The values we'll insert are the name, then the content, and the user ID. Then we say the values. Maybe this post is why I love corgis. The content is, oh my God, I love them. And the user who made them was user 1. He's a big corgi fan. We can go ahead and insert them. And then if we look at the post table, we're going to see, sure enough, the corgi post is there. Now let's go ahead and insert some more. So we'll bring back, I just undid a bit to get back to the insert post. Excuse me there. So we're inserting the post. Why I love corgis, OMG, I love them. Let's just say why I love dogs in general. So much. And it was also made by user 1. What did I do wrong here? Content, user ID. OMG, why I love this so much. I don't see it. Do you guys see it? You guys see where I made my mistake? I love them in general. Oh my goodness. Something good. This is a good call out. Something good to know about PostgreSQL is that if you highlight something and hit execute selection, it's just going to execute that. We want to execute the whole statement. Okay. I'm not going insane. This is correct. Okay. We inserted the post now. So if we go back and we say select star from post and end it with a semicolon, there we go. We've got these 2 posts in place. Okay, perfect. So we've got our 2 posts in place. That's great. And we can see that those both belong to user 1. And that's how we get that one-to-many, right? This user 1 has many posts because we've got 2 separate posts with the user ID 1. It works. Now the question is, how do we say I want the user along with their posts? That seems like an interesting piece of data to retrieve. The way that we select data from multiple tables is by leveraging a join. Now, there's multiple types of joins. There's an inner join, an outer join, a left join, and a right join. But diving into them super thoroughly is probably a good topic for a future Postgres video because we're just trying to talk about the basics. And for now, let's just talk about inner joins. So what we can do is we can start from the user table. So we'll go from the user table, select from user. There we go. There's our user data. And then what we can do is we can tell this table that it needs to also join to the posts table. Okay? So I'm saying select from users table, join it to the posts table. So we're going to combine those 2 tables together. And then we need to tell it on what place does it join. Well, it joins on where the post table user ID is the same as the user ID. So we've got these big tables. And what we're saying is wherever the post table has a user ID that lines up with one of the IDs of a user, we're going to match those things together. So what we'll see here is we'll see 2 rows because there's 2 separate posts, but for each one, they've lined up with the user ID 1 because we're joining wherever the post user ID is, the user ID. So give me, for a post, like this first post, or let's talk about the second one, like this second post, give me the user information where the user's ID, in this case 1, lines up with our post user ID column. And there we go. It lines up. So there's our join. But you might notice something here. We have 2 name columns, which is fine for us viewing it here. But what if we're using this in an application and these become variables in some other programming language? Well, you can't have variables with the same name in most languages, so it's probably useful to know how we can reference these things differently. Well, remember, the star means select everything, and we can change it up a little bit. We can say select everything from the user table. So we'll say user star, but then maybe from the post table, we'll get the post ID, the post name, but then we'll tell it to not call it post name. We'll say call it title, as title. Then we can say get me the post content and get me the post user ID. Now what you'll notice is when we run this, it's the same data, but it's gone ahead and it's changed, and it might be hard to see. But now the title of the post, or I should say the name of the post, is now called title. And that doesn't change anything in the table itself. It's just changing the results we get back with our select statement. So that covers the basics of joins. In future videos, we'll be talking about more complex joins, more complex schema design, as well as triggers, Postgres functions, and more complex constraints. Thank you so much for watching this video. If you found it helpful, please consider giving it a like, and if you have any feedback, it would be great to hear about it in the comments down below. I hope that this video was useful for you and helps you get started in Postgres. Please consider subscribing so that in the future, any additional content I release, you're able to get notified for, whether that's additional Postgres tutorials or just general software engineering advice and tutorials. You'll see it all on this channel, so subscribing is probably a good idea.